Actually, we got a gander at some enchanting pictures as the James Webb Space Telescope peers back toward the start of all that. This telescope has uncovered an exposure that challenges the foundations of our perception, captivating the interest of room specialists and analysts. This exposure shows a potentially Goliath event ready to change the universe as we currently see it. The significance of this finding is critical, raising stresses over the real reason for our pretentious presence. The request arises. Might this exposure anytime lead to the farthest reaches of all that we know? Is the universe very nearly a phenomenal event beyond our progressing understanding? Join us as we jump into the latest exposure from the James Webb Space Telescope and explore its potential to reshape our understanding of the universe. Our outing begins with an appraisal of the unmistakable universe, our window into the huge domain beyond the recognizable universe. This combines all that we would have the option to recognize, measure, and take a gander at with our telescopes and space missions. It is an assortment of stars, universes, and heavenly bodies visible to us, tending to just an insignificant part of the entire universe, a little piece of a tremendous, limitless puzzle that individuals endeavor to study and understand. Notwithstanding our movements, the general size and construction of the universe remain a mystery. The width of the observable universe is surveyed to be around 93 billion light-years. This astonishing figure results from various components, including the distance light can go in 1 Earth year. The age of the universe, assessed at 13.8 billion years since the Big Bang, induces that the recognizable universe expands 13.8 billion light-years in each bearing from Earth, provoking a diameter of, in any case, around 93 billion light-years. That's what Hubble's law exhibits. Space has been stretching out since the Big Bang, inciting the noticeable universe to broaden. Current measures suggest that things releasing light 13.8 billion years ago from a good distance of 13.8 billion light-years are, as of now, around 46 billion light-years away. This expansion proposes that the perceptible universe expands more than 46 billion light-years toward every way from Earth. The endless turn of events, begun by areas of strength for 1 billion years ago, has not only led to the universe developing but also accelerating. Confounding forces, for instance, bewildering dark energy, appear to be driving this speed increase, extending the universe's limits further apart. As the universe expanded, gravitational forces pulled particles together, prompting astounding structures like stars, galaxies, and planets, including our own Earth. In demonstration of the quantifiability of the universe, mechanical degrees of progress have allowed individuals to continually examine a greater measure of the universe. Specific telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, have engaged the impression of faraway stars and galaxies, making these wonders more accessible to the general populace. In considering the galactic field, it is intriguing to observe that even within our expansive nearby planetary group, the universe appears strangely void. The nearest star, if scaled back to the size of a quarter, would nonetheless connect with 2 soccer fields distant. This boundlessness grows just within our Milky Way galaxy, one of billions in the discernible universe, offering us a short glimpse into the tremendousness of grandiose size. As we continue with our examination, the new disclosure by the James Webb Space Telescope adds another layer of interest to our perception of the universe, inciting further requests concerning the possibility of our presence and the potential for momentous events on a limitless scale. You might be intrigued by why we can't see the entirety of the universe. There are a couple of explanations behind this cutoff. Despite light being the speediest object in the universe, it still requires time to travel through space. Therefore, when we notice faraway objects, we are fundamentally investigating the past. The farther a thing is, the more its light has branched out to reach us, making a sort of gaudy time machine that unravels the verifiable setting of our universe. As we witness galaxies millions, if not billions, of light years away, another vital factor at play is the expansion of the universe. Imagine the external layer of an inflated balloon. As the balloon expands, the spots on its surface move apart. Similarly, vast galaxies float away as the fabric of space expands. This expansion leads to an idiosyncrasy known as redshift, where the light produced by long-shot objects undergoes change, and frequencies are broadened toward longer, redder tones. A couple of notable bodies eventually outstrip a critical distance, showing up at the grandiose horizon, where their light is too far away to reach us due to the consistent improvement of the universe. Considering these two primary contemplations, the development time of light and the advancement of the universe, it's not surprising that we haven't seen the entire universe yet. Even with the most high-level telescopes and technology, our vision remains constrained by the significant components of the universe. We ought to delve deeper into these thoughts. The size of the universe is a moving evaluation in light years to show the distance light travels in a year. Our galaxy, the Milky Way, runs around 100,000 light years. Even within our universe, the closest star to our Sun, Proxima Centauri, is generally 4.24 light years away. When we explore space, we can see galaxies billions, or an enormous number, of light years away, allowing us a short glimpse into the early history of the universe. The mystery of the universe's edge has enchanted the interest of individuals from various fields. While definitive plans remain unobtrusive, three enormous speculations have emerged. The first suggests that the universe is immortal and colossal, with no evident endpoint, expanding consistently in all bearings. The second suggests a limited universe without an obvious edge, similar to a gigantic round or twisted space. In this present circumstance, traveling interminably in any direction would eventually take one back to the starting point, like circumnavigating the Earth. The third speculation, the multiverse theory, presents the chance of our universe being one among many, each with specific genuine standards and attributes. These universes might operate independently or be interconnected, forming a huge and baffling multiverse. Examining these theories sparks both logical and philosophical interest. The possibility of a ceaseless universe challenges our perspective on space and its hugeness. On the other hand, a limited universe without an edge challenges our considerations of limits and movement, suggesting the potential for repetitive models within the surface of space. The multiverse speculation, with its parallel universes. In reality, we got a gander at a few charming pictures as the James Webb Space Telescope peers back close to the beginning of all that. This telescope has revealed an openness that challenges the groundworks of our discernment, spellbinding the interest of trained professionals and examiners. This openness shows a potentially Goliath occasion prepared to change the universe from our perspective. The meaning of this finding is basic, raising worries about the genuine justification behind our vainglorious presence. The solicitation emerges. Might this openness never lead to the farthest reaches of all that we know? Is the universe practically an extraordinary occasion beyond our advancing? Getting it? Go along with us as we bounce into the most recent openness from the James Webb Space Telescope and investigate reshaping how we might interpret the universe's potential. Our excursion begins with an examination of the unquestionable universe, our window into the enormous space past the conspicuous universe. This consolidates all that we would have the choice to perceive, measure, and look at with our telescopes and space missions. It is a variety of stars, cosmic systems, and grand bodies noticeable to us, watching out for only an inconsequential piece of the whole universe, a little piece of a colossal, boundless riddle that people try to study and comprehend. Despite our developments, the general size and development of the universe remain a secret. The width of the recognizable universe is studied to be around 93 billion light-years. This surprising figure results from different parts, including the distance light can go in one Earth year. The age of the universe, surveyed at 13.8, a long time since the huge explosion, prompts that the conspicuous universe extends 13.8 billion light-years in each bearing from Earth, inciting a width of, regardless, around 93 billion light-years. Hubble's regulation displays. Space has been loosening up since the huge explosion, inducing the recognizable universe to widen. Current measures recommend that things producing light 13.8 billion years ago from a distance of 13.8 billion light-years are, at this point, around 46 billion light-years away. This extension recommends that the recognizable universe extends in excess of 46 billion light-years toward each way from Earth. The perpetual development, started by solid areas for a long time back, has prompted the universe developing as well as speeding up. Perplexing powers, for example, stupefying dim energy, seem, by all accounts, to be driving the speed increase, expanding as far as possible further apart. As the universe extended, gravitational powers arranged particles, provoking bewildering structures like stars, cosmic systems, and planets, including our own Earth. In showing the quantifiability of the universe, mechanical levels of progress have permitted people to look at a greater proportion of the universe ceaselessly. Specific telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, have drawn in the impression of distant stars and worlds, making these marvels more accessible to the overall public. In taking into account the cosmic field, it is charming to see that even within our extensive close by planetary gathering, the universe appears peculiarly void. The closest star, whenever downsized to the size of a quarter, would in any case interface with two soccer fields far off. This boundlessness develops just within our smooth waste system, one of billions in the recognizable universe, offering us a short look into the immensity of bombastic size. As we continue with our assessment, the new exposure by the James Webb Space Telescope adds one more layer of importance to our view of the universe, prompting further demands concerning the chance of our presence and the potential for earth-shattering occasions on a boundless scale. You may be charmed by why we can't see the entire universe. There are several clarifications behind this end. Notwithstanding light being the speediest article known to mankind, it still expects time to go through space. Consequently, when we notice distant articles, we are in a general sense researching the past. The farther a thing is, the more its light has spread out to contact us, making a kind of grandiose time machine that disentangles the irrefutable setting of our universe. As we witness worlds millions, if not billions, of light-years away, one more indispensable component at play is the development of the universe. Envision the outside layer of an expanded inflatable. As the inflatable grows, the spots on its surface move apart. Essentially, tremendous worlds float away as the texture of space grows. This extension prompts a peculiarity known as redshift, where the light produced by remote objects undergoes change, and frequencies are widened toward longer, redder tones. Several outstanding bodies ultimately exceed a critical distance, appearing at the pretentious skyline, where their light is excessively far away to contact us because of the steady improvement of the universe. Taking into account these two essential thoughts, the improvement season of light and the progression of the universe, it's not shocking that we haven't seen the whole universe yet. Indeed, even with the most undeniable level telescopes and technology, our vision remains constrained by the significant parts of the universe. We should dig deeper into these contemplations. The size of the universe is a moving assessment in light years to show the distance light goes in a year. Our world, the smooth way, goes around 100,000 light-years. Indeed, even within our universe, the nearest star to our Sun, Proxima Centauri, is by and large 4.24 light-years away. At the point when we explore space, we can see worlds billions, or a colossal number, of light-years away, permitting us a short look into the early history of the universe. The secret of the universe's edge has charmed the interest of people from different fields. While authoritative plans remain subtle, three tremendous theories have emerged. The first proposes that the universe is eternal and titanic, with no obvious endpoint, extending reliably in all directions. The second proposes a restricted universe without an undeniable edge, like a massive round or turned space. In this current situation, voyaging relentlessly toward any path would ultimately return one to the starting point, such as circumnavigating the Earth. The third hypothesis, the multiverse hypothesis, presents the opportunity of our universe being one among many, each with specific certified guidelines and properties. These universes could work independently or be interconnected, forming a colossal and perplexing multiverse. Examining these hypotheses sparks both intellectual and philosophical interest. The chance of an interminable universe challenges our viewpoint on space and its immensity. Then again, a restricted universe without an edge challenges our thoughts of limits and development, recommending the potential for dull models within the outer layer of space. The multiverse hypothesis, with its equal universes,